Yeah, it's a lot of wire mess on my couch, on my table. It's a battery discharger for NP50 batteries because I have made these chargers. You might have seen the video. I don't know. It's a completely different topic than the loudspeaker stuff. Um, but if you want to test, like, because my chargers charge like 12 batteries at a time, I have to discharge them again, of course, before I can put them in again to test the charger itself. And I only have a normal LiPo discharger / charger. So 12 times 2 hours or something, I don't know. That's 8 hours, and well, you have to run around all the time. When the thing is beeping, then you have to replace the battery and start all over again. So I really wanted to make something that discharge more batteries. This is an Arduino Uno, so it only has 6 analog inputs. So I can only make this a 6-bay discharger. The reason for that is I want to monitor the voltage on these batteries constantly, because it's not really nice for them to dip below 3 volts under load. That is, I mean, if there was no load, it should be a little bit higher, I even think. But so that's what it's doing actually. It's measuring the voltage constantly, and at the same time, it's looking at these resistors. We're not so much looking at the resistors, but he knows the values of these resistors. And with the resistor value, that's like parallel to the battery and quite hot, you can calculate how much amp is drawn. And well, it's not a set amount of ampere with a set resistor, because the voltage of these batteries will drop, so the amperage will go down. So that's what I did in this in the software part, is that it looks at the voltage. You can see I only use battery 1 and 2 at the moment. Battery 1 is 3.6 volts, and we know the resistor value, 8.2 ohms, give or take, because the wires have a resistance as well. And then it calculates the current it's drawing. In this case, it's 438 milliamp. And then in the column of milliampere hour, it calculates it back to, well, an hour. So it is drawing this at this moment, but it doesn't mean it can do that for an hour. And I'm interested in how much milliampere hour it is. So there's like well, you have to calculate that, but it does it over here. So as for now, it took out 275.6 milliampere hour so far, and they should end up around 600 or 700, I believe, if it was a full battery. So the first battery was almost full, the second one wasn't, so it is already at a lower voltage. And you can see the second battery has a lower voltage, not by much, but you can see that it draws less milliampere, 427 instead of 437. So that's the nice thing, because you can measure the voltage and you know the resistor, you can calculate the actual current drawn instead of eyeball it. Yeah. Oh yeah, and these relays are there. In my previous version, I didn't have the relays. They're gonna cut off the load, this resistor, when it reaches 3 volt. So it doesn't destroy the battery. Maybe I'll add a beeper as well. So if they're all done, so if they're all reach below 3 volt, or all the relays are off, that it makes a beeping sound, so I know I can change out the batteries. Because otherwise, well, I forget a lot, so might be the next day I'll look at it and I think, oh shit, they're done like half a day. or a day. So, tiny video about nothing related to loudspeakers. Just something I'm playing with, and for me it's all new. And I think it's kind of funny. I enjoy this stuff, although the amount of wires I don't enjoy, because I don't have the good wires. I even have to, like, you know, makeshift sort of make it work with the stuff I got. I don't have the money to buy like a gazillion piece of different crap for Arduino, and you know, these boards, for instance, these are Chinese cheap ass boards, and they're not so nice, including the wires. They're also kind of, I don't know, not the best. Would be nice to invest in something, you know, a kit or something, so you have always enough crap to play with. In this case, well, I have to do it with the stuff I got. And I use these blank, they were chargers, but I only use the housing as a discharger at this moment, because I make my own charger, so I don't need this housing. But it's a fast way to make a discharger in this case. See ya!